Welcome to David Alexander Maths Tuition. This is chapter 11I on the trapezium rule. Okay, so quick introduction to the trapezium rule. It's actually really easy. So let's say we wanted to work out the area under the curve between 2 and 7. So what I could do is I could turn this into some trapeziums, but the important thing is they all must be equally wide. So let's just make these into some trapeziums, and we'll call this trapezium 1, trapezium 2, 3, 4 and 5. Now hopefully you know the area for trapezium as a half of A plus BH. So trapezium 1, let's call this side A and side B. Trapezium B, we'll call this, well, this will be B, and we'll call this side C. For trapezium 3, we've got C, and we'll call this side D. And for trapezium 4, we'll call this E, and for trapezium 5, we'll call that F. So the area of trapezium 1 is a half of A plus B times H. Trapezium 2 is a half of B plus C times H. Trapezium 3 is 1/2 of C plus D times H. And trapezium 4 is 1/2 of D plus E times H. And trapezium 5 is 1/2 of E plus F multiplied by H. Now all of these parts in this long expression have a half h in it, so I can factorize out the 1/2 h. So that will be a half of h, and in brackets a plus b plus b plus c plus c plus d plus d plus e plus e plus f. So every letter repeats twice apart from the very first one and the very last one. So it's going to be a half h, a plus f plus 2 lots of b plus c plus d plus e, and that is the trapezium rule. So this is how the trapezium rule is presented in the formula booklet. As usual, a lot of the formulae look much more complicated than they actually are. So if we're integrating between b and a, then the height of the trapezium is b minus a divided by n, where n is the number of trapeziums. That hopefully seems fairly logical. So we've got half h that's been factored out, h0 and hn. So these are the side lengths of the trapeziums on the outside, which is why they only appear once, and then 2 lots of all the sort of side lengths of all the trapeziums that are attached to, well, the ones that are not on the outside. Okay, so here's an example of a question where we have to complete a table. So complete the table with the values of y corresponding to x is 4 and x is 6. Well, the y values are x minus 8 ln x, so just replace the x with the 4. So 4 take away 8 times ln 4, so negative 4 times ln 4, and that is minus 5.5452. And I'm going to do exactly the same thing with a 6. So 6 take away 8 is negative 2. So minus 2 times ln 6, which is negative 3.5835. So that part of the question is nice and easy. Okay, so for this question, what we're doing is we're using the x values of 3, 5 and 7. So we're ignoring the 4 and the 6. So we're trying to work out the approximate value for I, which is I is the integral of x minus 8 ln x between 7 and 3. So this is what we're trying to work out here, the area here. Now we've got one x values at 3, 5 and 7. So what that means is we are going to be turning this into 2 trapeziums. Okay, so remember half of half a plus b h. So what is the height of these trapeziums? Well, we can see it's a height of 2, which is the difference between 3 and 5 and 5 and 7. So you want to half that. So it's just going to be one lot of, and it's going to be the these side lengths added together. Now remember, it's just the ones that are not attached to another trapezium that don't get doubled. So it's one lot of, and again, because we're getting negative y values here because this is underneath the x-axis, but as we want an area, we're just going to ignore the fact that they're negative. So that's going to be 5.4931. So any sides of the trapezium that are shared, they get doubled. So plus 2 lots of 4.8283 plus 1.9459. That is the calculation we need to do. So 5.4931 plus 2 times 4.8283 plus 1.9459. So the area, on the approximate area, is 17.0956 units. Okay, this time we are going to use all of the x values. So here the heights of the trapezium are a half of 1, so it's going to be 1/2. And we're going to use all the side lengths. That's going to be 5.4931 plus 2 lots of 5.5452 plus 4.8283 plus 3.5835. And the last one we don't double because that's not attached to another trapezium. It's just the ones that are in the insides that have shared sides. So it's one lot of the 1.9459. Okay, so grab the calculator, 0.5 on the outside, 5.4931 plus 2 lots of 5.5452 plus 4.8283 plus 3.5835 plus the final 1.9459, which goes outside the brackets, does not get doubled. And well, we know from the previous question when we just used 3, 5 and 7, we got 17 point something. Here we're getting 17.6765. Now the more strips you use, the more accurate it's going to be. In the previous question we just had 2 trapeziums, which meant that we've got quite a lot of gap here. Whereas if we use thinner strips, we can see we've gained this amount of area here. So although there's a tiny bit of a gap there and a bit of a gap there, so it's not fully accurate, but the more strips you use, the more accurate the answer is going to be, because you're just filling in these gaps a little bit more. Okay, so the final part of this question is using integration to find the exact value. So here we're not using the trapezium rule at all, we're just using just normal integration methods. So it's going to be integration by parts. We're going to differentiate the ln x, so that's going to be 1 over x, and we're going to integrate the x, take away 8, so that'll be 1/2 x squared minus 8x. So the integral will be ln x multiplied by 1/2 x squared minus 8x minus the integral of these two things combined. So that's going to be the integral of 1/2 x minus 8. So it's going to be ln x multiplied by 1/2 x squared take 8x minus 1/4 x squared. Now that's going to be 8 minus 8x, so if we're subtracting it, that will be plus 8x. And that's going to be between the limits of 7 and 3. Okay, so putting 7 through the function, 1/2 times 7 times 7 minus 8 times 7, 56, that becomes minus 63 over 2 ln x, sorry, that's impossible to read, minus 63 over 2 ln 7, take away a quarter times, actually I'm just going to do minus 1/4 times 7 plus 8 times 7, which is plus 175 over 4. And now putting the 3 through the function, so how many ln 3s is that going to be? 1/2 times 3 times 3 minus 8 times 3, that is minus 39 over 2 ln 3, minus 1/4 times 3 times 3 plus 8 times 3 is plus 87 over 4. Okay, let me just take these workings up here now. So that is going to be negative 63 over 2 ln 7 plus 175 over 4 plus 39 over 2 ln 3 take away 87 over 4. Okay, so if I subtract 87 over 4 from 175 over 4, I'm getting plus 22. So that's going to be, I'll just put it, so negative 63 over 2 ln 7 plus 39 over 2 ln 3 plus 22. Okay, everything's correct apart from the signs. So we just need to be thinking, what is the reason for that? Well, the reason is because we're working out an area that is below the x-axis here. So that's why we're going to get this negative value. So we just need to flip all the signs. So that's going to be 63 over 2 ln 7, take away 39 over 2 ln 3, take away 22, which was what was requested. Okay, so here's another example, but this time the equation is a trigonometric equation, the sine of 0.2 theta. So for part A, all you need to do is complete the table of values. So what is y when theta is pi over 3? Well, that is the sine of 0.2 multiplied by pi over 3, and that is 0.2079. And what is the sine of 0.2 theta when theta is 2 pi over 3? Well, that is 0.4067, and that is the table complete. Nice and easy. Okay, so for part B, what we need to do is work out the height of these trapeziums. So what's pi over 3 minus pi over 6 is pi over 6. So the height of each trapezium is pi over 6. If I add pi over 6 to pi over 6, get pi over 3 plus another pi over 6 takes me to pi over 2. So if the height of the trapezium is pi over 6, I want half of h. So half of h is going to be pi over 12. So it's going to be pi over 12 lots of 0.1056 plus 2 lots of everything else with the exception of the last one, 0.2079 plus 0.309 plus 0.4067 plus 0.5. So remember, the first one and the last one don't get doubled, everything else does. In the formula booklet, they stick the plus 0.5 next to they put the first and the last together. Doesn't really matter. Anyway, when you type this into a calculator, you should end up with, to 2 decimal places, 0.64 units. And for part C, it's going to be an underestimate because the sine curve is concave. So that means if you put in a trapezium like so, then we are missing this little bit of area here. So the trapezium law, the trapezium rule for if it's a concave curve is always an underestimate. Okay, so for part D, we want to find the exact area of R. Now, so the equation of the curve was the sine of 0.2 theta, and the limits from memory were, let's go back and take a quick look, shall we? 5 pi over 6 and pi over 6. So 5 pi over 6 and pi over 6. Okay, so let's just do a guess, which would be the cos of 0.2 theta. Well, if I differentiate the cos of 0.2 theta, I'm going to get minus the sine of 0.2 theta times by 0.2. So first of all, well, the sign's completely wrong. So if I make that my guess negative, then that will make my check positive, which is good. But that will turn it into, probably easier if I think of this as 1/5 the sine of 0.2 theta. So my guess is too small because I'm getting a fifth and I want a full one. So therefore my guess was 5 times too small. So it has to be minus 5 cos of 0.2 theta. And that is between the limits of 5 pi over 6 and pi over 6. Okay, right, let's use the 5 pi over 6. So 5 pi over 6. So minus 5 cos 0.2 times 5 pi over 6. And I'm getting, let me just put the brackets up here. So minus 5 root 3 over 2, take away, and let's do the same thing this time with the pi over 6. So negative 5 cos 0.2 times pi over 6, and I'm getting minus 4.9726. Okay, so let's just let's put the two together. So minus 5 root 3 over 2 plus 4.9726, and I'm getting the area as 0.6424729811. Okay, well, this is not ideal because I've done a bit of rounding here. So you do often get these questions where you're calculating the percentage error. So what we need to do to work at the percentage error, So this is the exact value here, except it's not quite exact because I did a bit of rounding. So the error is the difference between the real thing, which is be 0.6424729811 minus what my approximation was over the 0.6424729811, and hopefully it's a pretty small error. And of course we need to multiply it by 100 to get the percentage. So let's just give that a go. So I'll keep that answer minus 0.64 divided by that previous answer, multiplied by 100. So the percentage error is 0.38%. Again, in an exam, it's unlikely you'd have, well, it's probably impossible for them to give you values that don't work that well. It was nice we got an exact value minus 5 root 3 over 2, but not ideal that I had to do some rounding, so already that throws off the percentage error a little bit. But I'm just chucking some questions together just to show you how it works, and generally speaking the percentage error should be pretty minuscule, but there we go. So remember to calculate the percentage error. It's the actual minus the what you got using the trapezium rule as a percentage of what the actual value is multiplied by 100.